We will learn about radio communication link. It is also known as Friis transmission formula. It actually tells about the receiving power or PR received by the receiving antenna. This formula is based on the concept of effective aperture. Okay. Now we will start by drawing a diagram. We have a transmitter, we have a receiver. So we have a transmitting antenna and we have receiving antenna. This is the effective aperture AET for transmitting antenna, and this is effective aperture AER for receiving antenna. The distance between the two antennas is given by small r. Okay. So this is a figure. Figure is a communication circuit with waves from transmitting antenna arriving at the receiving antenna by a direct path length of r. Let's start our derivation. So suppose PT is the power radiated by transmitting antenna and it has an effective aperture AET, while PR is the power received by the receiving antenna with an effective aperture AER, as we know about the receiver. Now assume that the antenna is isotropic. Isotropic means the antenna radiates equally in all direction, and this is the power density. So it is given by PT upon 4 pi r square. We know that it is P radiated, but here we write it as PT. So it is actually we know that it is for transmitting antenna. It denotes T denotes transmitting antenna. And if we simply multiply this by directional gain GT, then there will be more gain of antenna, that is SR will be increased in proportion, and that is given by PTGT by 4 pi r square. This is number equation 2. Now we want to find out about the received power, that the power received by the antenna. So as you can see, if AER is the effective aperture of the receiving antenna, it is given by received power by the power density. This is power density we have calculated for transmitting antenna. So what is PR? It is AER multiplied by SR. We know the value of SR, okay? It is PTGT by 4 pi r square, and it is multiplied by AER. This is given in watts. We all know the formula for effective aperture AET, which is GT lambda square by 4 pi, and if it is AER, it is GR lambda square by 4 pi. So by putting the value of this is GT. We can put the value of GT from here, okay? And now our equation becomes PR is equal to PT into 4 pi AET AER upon 4 pi r square lambda square. 4 pi will be cancelled out, and we get the received power in terms of transmitting power. Okay, so it is PT AET AER divided by r square lambda square, where PT is the transmitted power in watts, AET AER are the effective aperture of transmitting and receiving antennas respectively. R is the distance between antennas and it is given in meter. PR is the received power and lambda is the wavelength. If you calculate the ratio, it is dimensionless. This is known as a Friis transmission formula. You can also get this equation in terms of gain. Okay, how you will get this? I have also told you that AET is GT lambda square by 4 pi, AER is GR lambda square by 4 pi. So you can put at the value at the place of AET and AER, you can write this value GT lambda square by 4 pi, GR lambda square by 4 pi, and hence you will get this formula PT GT GR lambda upon 4 pi r whole square. This is the alternative formula for radio communication link or Friis transmission formula. So what you get at the end, that you get is the received power is dependent on transmitting power and gain of the transmitting antenna. It is also dependent on the gain of receiving antenna. It is also dependent or inversely proportional to the square of distance between the two antennas. If you like this video, please like, share and subscribe my channel. Thank you.